Hey everyone, so today we're going to work on rational expressions, day one. We're going to be talking about domain and then simplifying, multiplying, and dividing. So what is a rational expression? Rational expressions are an expression p over q where we have two polynomials p and q. So for example, x minus 10 over x plus 2, or we could have something like that, x plus 4, x minus 1, y minus 3, y minus 3. Okay, so we're going to be talking about the domain, and really what domain means, if you guys remember from Algebra 1 a little bit, domain just means the set of all real numbers that the expression is defined on. Here's really what we're looking for. We can plug in any number except when the denominator is equal to 0. So we're going to be looking out for those specifically. Okay, so let's take a look here. We're going to find the domain and then simplify. So the first thing you want to do is set that denominator, any factors in the denominator, to 0. What numbers can I not plug in? I can plug in any negatives, any positives, 0, except I can't plug in when x plus 2 is equal to 0, aka negative 2. Okay, because if I plug in negative 2, I would get negative 12 over 0, which is an issue, right? That is undefined. If I plugged in 10, I would get 0 over 12. 0 over 12 is actually just 0, so that's fine. It's only when that denominator is equal to 0 that we really have an issue here, guys. So basically what we have here is all real numbers, except x cannot be negative 2. Okay, it's written in a couple different ways, so I just wanted to show you. We're also going to be talking about writing it in interval notation. Interval notation would be something like this. If I have all real numbers from negative infinity up to negative 2, I don't include negative 2, that's a parentheses there, union from negative 2 to infinity. So I'm not sure you've seen this. This is really like as though you had a number line and you could fill in all the dots except negative 2. Continue, continue, continue. So that's what this is saying. It's saying negative infinity up to negative 2. Parentheses means don't include it. Union, up, well, take negative 2. I could do anything above that. Negative 1.999999 up to infinity. Okay, so now let's talk about simplifying. Okay, this is much more than you need to write. Typically, I'll only write the domain as the interval notation. Now, simplifying. If I said to simplify this, okay, the algebraic issue that comes up is people love to do this. Okay, write yourself a note. Okay, you cannot cancel pieces of a polynomial. Okay, the only things that we can cancel are full binomials matching binomials, things that are factored out and multiplied together. Okay, so I want you guys to take a look, and if you don't believe me, you could make up a little problem for yourself. If I had 1 plus 2 over 1 plus 3. Okay, well, if I canceled out the ones here, I would get 2/3. Okay, but what if I actually did what I was supposed to do, which is order of operations? 1 plus 2 is 3, 1 plus 3 is 4. Is 3/4 the same as 2/3? No. So that's another little mini proof. Why can I not cancel out pieces of a binomial? So this is actually simplified. That is all you can do. Whoa. And that's the final answer there. Okay, let's take a look at the next one. So again, the first thing we're doing is looking for that domain. Okay, I look at the denominator. I set each one of these equal to 0. And specifically, it's when x is 1 and when x is 3 is where I'm going to have these issues. Okay, so at 1 and 3, I can plug in all real numbers, okay, except x cannot be 1 or 3. Notice I did this before simplifying, and we would write that from negative infinity up to 1, and everything between 1 and 3, skip over 3, everything from 3 to infinity. So we're going to practice writing this. You know, it kind of depends on who you are. If you've seen this before and you're comfortable with it, if this is totally new and foreign to you, we're going to keep working. Again, really what this means is with those parentheses, we're skipping over the value of 1, skipping over the value of 3, but mentioning all other values involved. Now, if we are simplifying this, we can because we have an x minus 3 that matches an x minus 3. They're multiplied together. They're two factors we can cancel out. So our final answer here would be x plus 4 over x minus 1. Notice I took my restrictions before I canceled though. Okay, so even though x minus 3 canceled out, it's still a restriction for this problem. All right, and let's try one more here, guys. Again, I'll ask you, can you do this? X squared, cancel them out. No, you cannot. Biggest mistake in this chapter. If you cancel out pieces of a binomial or pieces of a trinomial, you will get all of these problems wrong. So be really, really cognizant of that. So what you're going to do is actually factor, aka why we just did factoring. We want to be really comfortable with rewriting these in factored form. Okay, and so from here, again, notice I didn't cancel yet. I want to look at my restrictions. So I can't have x equals 3. Again, I'm setting each of these to 0. I can't have x equals 2. Those are the two things that if I plugged them in, I would get an undefined fraction. So my domain here, what are the things I can plug in? I can plug in all the negatives up to 2. Union, I could plug in everything between 2 and 3, like 2.5 would work. And then I have to skip over 3, but I can plug in everything up to infinity. Okay, so that would be my domain, all real numbers except for 2 and 3. And now we're going to actually try simplifying. So take a look at your fraction up here, those factors multiplied together. Do I have any matching factors? Yes, I'm canceling out a full binomial with a full binomial. And my final answer is x plus 3 over x minus 2. Okay, so now we're going to dive right in. Let's get into the simplifying, multiplying, and dividing. Okay, pause if you need to. Take a look at that domain. We're not going to talk about domain for the rest of these problems, if that's okay. And you don't need to mention domain unless I specifically ask about it. So typically these answers will just be the simplified version is your final answer. So we've got things simplified, or excuse me, factored for us already. So this should be a pretty quick one, kind of satisfying to cross out. X plus 2 and 2 plus x are exactly the same. Now I want you to think about y minus 3 and 3 minus y. Okay, hopefully you guys are thinking x plus 1 and x minus 1 are not the same. But 3 minus y, if I take 3 minus y and I factor out a negative 1, that would be negative 3 plus y, which is negative 1 times y minus 3. Here's really what I have. I have y minus 3 over negative y minus 3. So when you see these opposites, okay, y minus 3, 3 minus y, 4 minus x, x minus 4, x minus 2, 2 minus x. These cancel out to be negative 1. So you'll notice I'll put a negative in front and circle it because really that's all that's left here is a negative. So my final answer would be negative x minus 1 over x plus 1. You can distribute the negative, but you definitely don't have to. And you only can have it in one spot. So it could, be down here, but typically it's in the numerator or right out front. Okay, be careful with how you write this. Make sure you have those parentheses if you're gonna put the negative in the numerator. Okay, let's take a look at the second one here. Again, factored for us, pretty much. We're gonna finish it up here. 3x plus 2's. I've got x minus 1, x plus 1, coming from my x squared minus 1, difference of squares. X squared minus 4, that's x minus 2, x plus 2. And finally, I have an x plus 1. Okay, so I just wanted to point out the difference. When cubed is on the outside, right, we're talking about 3 of the same parentheses. If we have this difference of squares, that's x minus 1, x plus 1, those opposite signs. So I'm going to take a different color here, start to cancel out. Again, this is kind of the fun part. What can cancel? One of these guys, one of these guys. I think that's about it. So numerator, I have 2x plus 2. So I could either write it as it is. I could be a little fancy and write that as x plus 2 squared. And I have x minus 1 over an x minus 2. Again, nothing else can cancel. X plus 2 over x minus 2 cannot cancel. X minus 2 over 2 minus x cancels to negative 1. So that's the slight difference there, so be careful. Okay, so now I'm going to throw us into some multiplying and dividing. The nice part here is, guys, when you multiply or divide fractions, for example, if I'm multiplying fractions, I simply multiply across, 3 over 8, and then I would simplify if I could. So really when I'm doing these, it really is just one big fraction, but I'm gonna start factoring first before I multiply or divide. Okay, dividing, what happens with division? If I have 1/2 divided by 3/4, you keep the first number, change the sign to multiplication, and multiply by that reciprocal. So same thing is gonna go here, all right? So again, we're doing a lot of factoring. If you guys look ahead here, you'll see it's a lot of factoring going on. Now, this first one doesn't have much factoring, but it does have some stuff we can cancel. So let's take a look. First, I'm going to rewrite this with multiplication and that flipped fraction. So before I do anything here, I'm going to flip my second fraction and multiply. Okay, from here, you can kind of start canceling some stuff out. It just depends on how much you technically could just multiply across and then simplify. I'm going to do a little bit here. I'm going to do 15 and 9 is 5 and 3. I think it's about it. Well, yeah, I'm just going to leave it like that for now. Let's see what we get. Actually, well, here we could do 10 and 6. That's 5 over 3 again, right? Take out a 2 from 10. Yep, okay. And so if I multiply across here, I get 25 p to the 5th over 3 times 3 is 9, p to the 3rd. Again, I have p squared times p. And then I want to cancel these out, of course. I end up with p squared. So 25 p squared over 9 is your final answer. For some reason, when people get perfect squares, they just like automatically want to square root. You cannot just randomly square root. So this is done unless it's equal to x or something. You know, we can't do any random square rooting. So that's about it. Now, again, you could have multiplied across and then simplified later, and you'd get the same answer as me. Okay. So I want to try out 2 more here. We'll save 1 for class because I think this is kind of a tough, fun one. I'll put it that way. So let's take a look at the next one. Again, I look at this. I know I can't cancel anything yet. 25 and 5 I could deal with. But the polynomial pieces, I definitely want to factor. So x squared plus x. We've got a GCF of x. xy plus y. We've got a GCF of y. And notice we are multiplying. So pretty much we're good to go here. Again, anything numerator, denominator, no matter what side is good to cancel. So 25 and 5 could cancel. And then again, even though they're not in the same fraction, we have numerator, denominator. I said that backwards, but denominator and numerator canceling. And now we just have x and 1 over 5y is our final answer. And again, that's really because when we're multiplying, technically all of this is together, x times x plus 1, and technically all of this is together, 5y x plus 1. So that's why those are able to cancel. You do not need to rewrite it if you don't want to. Okay, and then let's try, like I said, we're going to try one more, save one fun one for class, and be good to go here. So you look at this. You do not cancel out the m squareds. You would never do that. You promise. You pinky promise me you won't do that. Okay, no canceling out pieces. You see this and you're like, every single time we factor. So let's start off with some factoring. I also notice I have division, so I also know I'm going to end up flipping this fraction. So this guy, numerator over here, what multiplies to 2 and adds to 3? That'd be 1 and 2. Denominator over here, what multiplies to 4 and adds to 5, that would be m plus 4 and m plus 1. Nice easy factoring going on here. Now I have times, be careful, I'm going to factor this and it's going to go on top. M plus 6 and m plus 4. What multiplies to 24 and adds to 10. And then in my denominator here, I've got what multiplies to 6 and adds to 5, m plus 3, m plus 2. Okay, now, if I paused and said, what would be the domain here? What would be the domain? Look at, we have a couple issues here. So what values could I not have? All right, specifically, I could not have -4, -1, -3, and -2. Those are all prohibited from being plugged into this problem because they would make the denominator 0. So again, that would be a really annoying domain to write out as interval notation. But in general, you should always have that in mind, that those would be those domain restrictions. From here, nicely, we just get to, again, this is really when you're multiplying, it becomes one big fraction. So now we can just multiply anything on the top and bottom. We can cancel those guys out. And this is the fun part. M plus 2, M plus 2, M plus 4, M plus 4, M plus 1, M plus 1, M plus 6 over M plus 3. We would never cancel out the M's there, or the 6 and 3, because again, those do not match, and we do not have anything factored out. And that's about it, guys. So that would be your final answer. After all that factoring, this problem simply becomes that. Okay, so as I mentioned, we're going to try this one in class. I want you guys to think about, how do we factor 4 terms? And that's going to really come in handy here. So thank you so much for watching, and please let me know if you have any questions.